Hello there. In this video, I'm going to discuss about projection. And first of all, I will show you how to calculate the projection of a line segment on a line. So let us consider a line PQ. PQ is a given line. So we will find the projection of PQ on the line segment X dash, we can say. Let us say this line as X dash. So to find the projection of PQ on this line X dash, first of all, let us draw the perpendiculars from the point P on the line x dash, and let us name this point as P dash, and let us also draw a perpendicular from point Q on the line x dash, and let us say this point as Q dash itself. So now P dash Q dash is the projection of the line segment PQ. So P dash Q dash is the projection of the line PQ, we can say projection of PQ. So again, let us draw the perpendicular from P on Q dash, and let us say this point as R. So this is a perpendicular. Now let us consider that this PQ makes an angle theta with this x dash, because if we go on producing this line PQ, so this cos x dash somewhere else, so this angle between this line PQ and x dash can be considered as theta. So being parallel lines, this angle QPR will also be theta, because they are corresponding angles. Now in right angled triangle PRQ, we need this, we are calculating the projection of PQ, isn't it? So we need this side, so we now take cos here. So cos theta equals to, cos means curly brown here, so base upon hypotenuse, because this is the reference angle over here. So we are taking cos theta equals to, base means PR upon PQ, is it? PR upon PQ. So or this will be PQ cos theta equals to PR. So now here PR, and this PR equals to, see, PR equals to P dash Q dash, because they are opposite sides of a rectangle so formed here. So we can write here, instead of PR we can write P dash Q dash here, or PQ cos theta equals to P dash Q dash. So what did I say before? P dash Q dash is the projection of the line PQ. So PQ, projection of PQ is P dash Q dash. What we get? P dash Q dash equals to PQ cos theta. So P dash Q dash, instead of this we can write projection of PQ. So what conclusion do we make? We are finding the projection of PQ on x dash. Then what is our conclusion? We got projection of PQ on x dash equals to PQ cos theta itself. So have a look, and if you need it, you can take a screenshot of it as well. Okay, you can take a screenshot of it. Okay, now let us discuss how to find the projection of a line segment joining two points P and Q on another line AB with direction cosines element. So here let us consider this line PQ whose coordinates of P are x1, y1, z1, and coordinates of Q are x2, y2, z2. We need to find the projection of PQ on the line AB, and DCs of AB are given as L, M, and N. DCs of AB are given as L, M, N. So in this case, I will directly say the formula as I have derived earlier. Projection of a line PQ on x dash is PQ cos theta. Likewise, the same process will repeat here, but that is not required. That was general concept only. So I will directly talk about formula, because it's very much important and it's needed. So whenever a line whose endpoints are given, coordinates of endpoints are given, and we need to find the projection of that line on another line whose direction cosines are given. Now students, you keep one thing in your mind: the line whose direction whose projection is to be find out, its direction ratios should be calculated. We need to find the direction ratios of the line PQ, and we need to find the direction cosines on which the projection is to be found. So here we need to find the projection of line segment PQ on AB. So if two different lines are given, for example, if it is not mentioned anything, if both coordinates are given, if the coordinates of A and B are also given, then we need to calculate the direction cosines at that time. So I think you have understood now. For PQ, we need to find out direction ratio, whereas for AB, we need to find direction cosine. So here we can say that projection of PQ on AB equals to, so there is a formula, and that is x2 minus x1 times L plus y2 minus y1 times M plus z2 minus z1 times n. So here, as we have already discussed, x2 minus x1, y2 minus y1, z2 minus z1, these are the direction ratios of the line PQ. So direction ratios are basically denoted by A, B and C. So x represents x2 minus x1, A represents x2 minus x1, B represents y2 minus y1 and C represents z2 minus z1. So we can write this AL plus BM plus CN. So always keep one thing in your mind. So projection of PQ on AB is direction ratios of the line PQ and direction cosines of the line AB. So, and we just multiply the corresponding let's say elements and add them. Hope you got this point. So you can take the screenshot if you need it. Now let us discuss one question related with projection. The projection of a line on the axes are 6, 2, 3. Find the length of the line and its direction cosines. So this question means that, so this is the coordinate axis. This is the coordinate axis. Let us consider this as x-axis, this as y-axis, and this as z-axis. So let that line, we can suppose that line as PQ. It's very easy, isn't it? So according to the question, the projection of a line on the axes are 6, 2, and 3. So we have considered the line as PQ. The projection of PQ on axes means on x-axis it's 6, on y-axis it's 2, and on z-axis it's 3. Okay, so we'll be doing with x-axis only, and we will say similarly with y-axis and z-axis. So as I have already told you, we are going to find out the projection of the line PQ on OX, and it's 6 already given, isn't it? So according to the formula just we discussed before, we need the direction ratios of the line PQ and DCs of the line OX. So what are the DCs of the line OX or x-axis? Obviously, yes, 1, 0, 0. These are the direction cosines of the x-axis, isn't it? So we can consider the direction ratios of this line PQ as always we consider direction ratios as ABC. So if we suppose the direction ratios of the line PQ as ABC and direction cosines of line are, it's universal, isn't it? It's already known, 1, 0, 0. So projection of PQ on x-axis is given as 6. It's given from question, isn't it? So what is projection of PQ on x-axis? So for calculating the projection, we just multiply the corresponding these elements, direction ratios of PQ and direction cosines of x-axis. So what it becomes, A multiplied by 1 plus B multiplied by 0 plus C multiplied by 0 equals to 6. If you don't understand this step, just repeat this and see the previous one where we have discussed how to find the projection of a line on another line, isn't it? There we discuss about this formula. So I easily get A equals to 6 over here. So similarly, if I go on doing this, I will get B equals to 2 on y-axis and C equals to 3 on z-axis, isn't it? And one more thing, in direction ratios and direction cosines, we have one relation. Suppose if the distance of or length of PQ we consider as R, and if we consider the DCs of PQ as L, M, N, we have the relation L equals to A upon R, M equals to B upon R, and N equals to C upon R. So this implies LR equals to A, MR equals to B, and NR equals to C. We have already calculated the value of here. So just see here, A, B, and C. We have already calculated the values. So simply put here 6, 2, and it's 3, isn't it? These 3 different quantities. Now LR equals to 6, MR equals to 2, NR equals to 3. So squaring and adding these 3 terms, we can easily calculate the value of R here. So the solution of this question goes like this. Hope you understand up to here. So if you understand this, then you can easily solve this. If you didn't understand this, you repeat it, see it again, you will understand. So here goes the solution. So I have considered the line PQ whose line direction ratios are ABC and its direction cosines as LMN. So, and I have considered the length of PQ as R units. So, L equals to A by R, M equals to B by R, N equals to C by R. You already know this relation. So, we know the direction cosines of x-axis, y-axis and z-axis are like this. You understand this one also. So, from question, projection of a line PQ on x-axis is 6. So, I have done this there, isn't it? You understand over here. So, A means LR. A means LR equals to 6. So YOMR and NR equals to 2 and 3. How? I have already discussed about these things. So squaring and adding the results, these three results, this one, and this one, we get this relation, isn't it? So R square is common, L square plus M square plus N square. You just simply calculate here, it's 49. So L square plus M square plus N square equals to 1, isn't it? So this equals to 1, it's all right. So R equals to plus minus 7, but its length, that's how we are taking only the positive sign here. So the length of the line PQ is 7 units, and we need to find the direction cosines as well. So direction cosine LMN equals to A upon R, B upon R, C upon R, which is 6 upon 7, 2 upon 7 and 3 upon 7 respectively. So please take a screenshot if you need it.